Hello, my name is Emily Cato, and I'm here to talk about my research regarding the use of Pleurotus ostreatus mycelium to remediate contaminated areas. In light of past events, including the Gulf oil spill of 2010, researchers have been focusing more and more time on developing remediation techniques to aid in cleansing contaminated areas. This subject is exceedingly interesting to me due to its real-world application and relevance. This investigation studied the possibility of using Pleurotus ostreatus mycelium to break down petroleum products. Pleurotus ostreatus is more commonly known as the pearl oyster mushroom and has been proven to break down hydrocarbons by way of exuding extracellular enzymes. This project studied the application of its mycelium rather than the fruiting fungus itself in expunging motor oil from contaminated soil. It was predicted that a decrease in petroleum content would occur. In order to test this hypothesis, 6 batches of oyster mushroom mycelium were grown on wood chips and recycled cardboard over the course of a week. Then, the mycelium colonized substrates were placed in a layer on top of contaminated soil and left to further colonize. Even though actual colonization of the mycelium was less visible as time lapsed, when the data was collected, there was a definite but small decrease in petroleum content, as much as an 8.75% difference in petroleum levels between control and experimental averages. These results obviously supported the hypothesis, and hopefully if this experiment can be replicated and data validated, similar techniques may be utilized in the future in a real-world setting. In order to test my hypothesis, I used the following materials and procedures. I used 12 milliliters of Pleurotus ostreatus spore culture in the syringe, 60 grams of cypress mulch, 60 grams of corrugated cardboard cut into 2 centimeters by 2 centimeters pieces, tap water, 6 474 milliliter wide lid mason jars with lids, cling wrap, an autoclave, 1,422 milliliters of motor oil, Scott's potting soil, I used 7,200 grams of that, 12 clear plastic bins, and a Dremel. Using the Dremel, drill 4 evenly spaced holes on each of the jar lids. Mix the cardboard and mulch together and add 778 milliliters of tap water to the mixture, making sure that it's mixed evenly. Add 30 grams of this mix to each of the jars. Once all of the jars are prepared, sterilize in the autoclave at 15 psi for 35 minutes. Wait for the jars to cool completely, which takes approximately 2.5 hours. Sterilize the tip of the syringe needle by holding it over a flame and letting it cool. Then, using the syringe, inoculate the substrates by adding 0.5 cc of culture to each hole of the jar lid. Cover the holes with cling wrap. Place the jars in a dark place where they will remain undisturbed for 7 days. At this point, the jars will be partially colonized with mycelium. To prepare the soil, separate it into 6 of the clear plastic bins, 600 grams per container. Each of the bins will be contaminated with motor oil, 237 milliliters per container. Separate the water into the remaining 6 bins and contaminate with motor oil. Now remove the mycelium from the jars by tapping firmly on the bottom. Place each of the 6 mycelium samples into the 6 bins, spreading in a layer on top of the contaminated soil. The remainder of the contaminated bins will serve as the control group. Place the bins in an area that is well ventilated and where the bins will remain undisturbed. After 1 week, extract 20 milliliters of soil from each bin and using the water shake method, measure the petroleum content and calculate the approximate percent petroleum in each test. Also, record visible observations on the further colonization of the mycelium. From the data collected, I can conclude that the hypothesis was indeed supported to a certain degree. A small decrease in petroleum content was reflected. However, whether it was the result of the actual breakdown of hydrocarbons by enzymes or the absorption of the products by the mycelium remains unknown. Also, the temperature of the environment in which the subjects were placed could account for some minor evaporation of the motor oil. Even though the hypothesis was supported, I would like to continue investigation in order to further affirm the conclusion. Also, it would be beneficial to further research the effects of mycelium and even the actual fruiting of the mushroom. In order to test this, I could attempt to grow Pleurotus austratus mycelium on contaminated areas rather than just trying to spread it from substrate to contaminated medium. Also, floating pieces of mycelium in contaminated water simulating an oil spill may be another avenue to explore. In conclusion, the hypothesis was supported to a certain degree, but further testing is required to solidify this conclusion. This subject still remains of great interest to me and would most definitely be further investigated.